Hello everyone, I am Aryan Kumar from Bangalore Institute of Technology, and today I am gonna talk about the topic binary search using recursion. And in today's video we are diving into one of the most efficient search algorithm in computer science, which is found to be binary search, and we will be exploring it by using the recursion. In whether you are preparing for the coding interviews or strengthening your DSA fundamentals, understanding the mechanism of binary search is a must. So grab your compiler and let's get started. Introduction to binary search. Binary search using recursion is an efficient search algorithm that operates on a sorted array by comparing the target value to the middle element and recursively searching in the left or right subarray depending on the comparison result until the target value is found or the subarray size becomes 0. Binary search is an efficient algorithm for finding an element in the sorted array. It reduces the problem size by half at each step. Time complexity it has big of log n, big of log n, making it much more easier or usable than the other searching techniques like linear search, which has a time complexity of big of n for a large data set. It requires elements to be in the either ascending or descending order. Binary search is a search algorithm that divides the sorted array or a list in half with each iteration until the target value is found or the size of the intervals becomes 0. How binary search will work? Binary search works by comparing the target value to the middle element of the array. If the target value is equal to the middle element, the search is done. If the target value is smaller than the middle element, the search continues in the lower half of the array, and if it is larger than the middle element, the search continues in the upper half. Here compare the middle elements with the target. If the E is equal, element found and return the mid element index. If the target is less than mid element, searches in the left subarray. If target is greater than mid element, searches in the right subarray. Repeat the process until the element is found. Algorithm start with the low and high indexes of the sorted array. Check if the low value is greater than high, then the element is not present in the array. Return -1 to the calling function and find the middle index value by calculating with the formula low plus high divides by 2. Compare the target element with the middle element. If the target value is equal to the middle element, return the index of the middle element and which is and return print the statement element is found. And if the key value or target value is less than the mid element, recursively search the left subarray part from low to mid -1. And if the key value is greater than the mid value, then recursively search the right subarray part from mid +1 to high. Repeat the steps 2 to 4 until the element is found or the search space become empty. And function takes the parameter of binary search array low index, high index, and key value. If the low value is greater than high value, return -1, and it indicates that the element is not found or the element is not present in the array. And calculating the mid value as a low plus high divides by 2. If the mid value is equal to the key value or target value, return the index of the mid value, and else if key value is less than the mid value, then search in the left subarray part by calling the function binary search, which takes the parameter as array low value, mid -1 value for the high value, and key value. And if the element is present in the left subarray, then again calling the binary search using recursion. And if the element is found, then simply return the element of the mid index. Else if the target value is greater than the mid value, recursively call the function for the right subarray part, which takes the parameter array and low value as mid +1 and a high value and a key value. And here is the full source code of a binary search using recursion. And it starts with the parameter taking low value, high value, and a key value. Here is the source code, and execution starts from the main function. B passes the array as a 2 4 7 10 13 18, and size can be calculated by calling the size function. And target value or key value is 13, and result will store the final result of the result of the value returned from the calling function binary search. If the result value is not equal to -1, printf element found at the index, which is the middle element, and which is given by the calling function. else printf element not found or element it is not present in the array. Here is the tracing. Tracing, we take input array as a 2, 4, 7, 10, 13, 18, 21, and the key value is 13. Starting with the steps. Initial call for the binary search takes the parameter as an array and in a low value as a 0 and a high value is 6, which is the last index element, and the key value as a 13. Calculating the mid value as a 0 plus 6 divides 2, which is found to be 3, and the element at the third index is 10, which is lower than the target value, so search in the right half. So calling the function binary search for the right half, which takes the input as a array and a low value as 4, high value as a 6, and a key value as a 13. And in the second call, binary search takes the parameter as a array, low value 4, high value 6, and a key value 13. Again calculating the mid value, 4 plus 6 divides 2, which is found to be 5, and the elements at the fifth index is 18, which is lower than which is greater than the target value, so search in the left half. And again calling the recursion, again calling the function binary search by passing the parameter as an array, and low value as a 4, high value as a 4, and the key element is a 13. And in the third call, binary search takes the parameter low value 4, high value 4, and the key value 13. Calculating the mid value as a 4 plus 4 divides to 4, and element at the fourth index is found to be 13, which is equal to the key value or target value, so match is found. So simply return the mid value index 4 to the calling function, and the search is done, and the searching part is done, and the element found at a fourth index. And advantages and limitation of binary search. Advantages: binary search provide faster search time than the linear search, reduces the number of iteration or number of comparison needed, and is widely used in sorting algorithms under data structures like arrays and a binary tree. It has a fast time complexity of big of log n, which is making it much more efficient than the other searching techniques. It has a simple recursive logic. And the limitation: it requires a sorted array stack overflow for very large arrays due to recursion. Applications: it is widely used searching techniques in today's world. Application: searching in the databases for large data sets, games leaderboard, version controls, example git bisects, dictionary lookups, etc. And it's done. That's it for today. Thank you.